I want to do some problems out of the second half of section 2.6, and these problems are going to be absolute value inequalities. Now, the way we're going to do these problems are very similar to how we did absolute value equations. So let me just I'm going to work 3 problems, and as I'm working these problems out, I will describe to you what I'm doing. I gave you the steps in class, so here are 3 examples. First example, absolute value of x plus 5 minus 6 less than or equal to negative 1. So we're going to try and solve this inequality. Solving this inequality means let's find the values of x that make this statement true. And it's probably going to be an interval. As a matter of fact, for this problem, we're going to give the answer both as a graph and as an interval. The first thing you do is get the absolute value by itself on one side. Right now it is not by itself. I need to get rid of this minus 6. Once again, I treat this inequality as sort of like an equation. If I want to get the absolute value by itself, I need to add 6 to both sides. So I have absolute value of x plus 5 less than or equal to 5. Okay, the absolute value is now by itself. Now what I have to do is just check my number. If the number happens to be negative, I'm going to stop and just think about it, and I'm not going to do any math. But in this case, the number is positive, so it's going to get broken up into 2 problems. On the left-hand side, we simply drop the absolute value signs, and we solve this equation. If I subtract 5 from both sides, end up with x less than or equal to 0. Now the second problem, this is a little more complicated. I drop the absolute value signs, I flip the inequality, and I make the number a negative. So there are 3 things you do. You drop the absolute value signs, you flip the inequality, and you make the number negative. Now I'm going to solve this second equation. Subtract 5 from both sides. Now I have x greater than or equal to negative 10. Now I'm going to go and I'm going to graph both of these inequalities on the same number line. So x less than or equal to 0, here's 0, less than or equal to 0 is a bracket, and I'm going to head off to the left. And now x greater than or equal to negative 10, there's negative 10, I'm going to put a bracket and head to the right. Now for these absolute value inequalities, 2 things can happen when you create your graph. If the 2 graphs intersect, then the solution is where the graphs intersect. That interval is the solution. In a minute, I'm going to do a problem where the graphs do not intersect, and we'll talk about what the solution is for that situation. So for this one, the solution is the interval from minus 10 to 0 with brackets on both sides. All right, let's do another problem. Here's my second problem. Absolute value 2x plus 1 plus 3 greater than 8. All right, follow the same steps. First, get the absolute value by itself. So I'm going to subtract 3 from both sides. So when I do that, let me write it here just in case you're unsure. When I do that, I end up with absolute value of 2x plus 1 is greater than 5. Okay, now I have the absolute value by itself. I check my number. My number is positive. So I'm going to break this up into 2 problems. On the left-hand side, I simply drop the absolute value signs and solve this inequality. So I'll subtract 1 from both sides. 2x greater than 4, and then divide both sides by 2. End up with x greater than 2. Now the other inequality, I drop the absolute value signs, I flip the inequality, and I make the number a negative. Now I'm going to solve this inequality. If I subtract 1 from both sides, I get 2x less than negative 6. If I divide both sides by 2, I have x less than negative 3. So now I'm going to go graph both of these inequalities on the same number line. X greater than 2. I go to 2, a parenthesis, I head off to the right, and now x less than negative 3, a parenthesis, and I head to the left. Now, unlike the first problem I did where the graphs intersected, in this case, the graphs or the lines do not intersect. So the solution is, in this case, both graphs. So you can, let me write, the solution is both this interval and this interval. The way we write that is, I write the first interval, the interval on the left, it starts at negative infinity, and it goes to negative 3 with a parenthesis, and I union it with the interval on the right, which starts parenthesis 2, and it goes to positive infinity. So there's the solution to that absolute value inequality. So the first example, the 2 lines, when we graph them, crossed. The second example, they did not. Let me just do one more example. This one looks a little complicated just because of a fraction, but really, I don't think it's too difficult. 2 minus 3x over 5, absolute value, all of that, greater than or equal to 2. All right, the first step is get the absolute value by itself. Well, it's already by itself. Second step is check the number. The number's positive, so I'll break it up into 2 problems. The left-hand side, I simply drop the absolute value signs and solve this. Multiply both sides by 5. That's how I'm going to get rid of this 5 in the denominator. So 2 minus 3x greater than or equal to 10. Now I'm going to subtract 2 from both sides. Negative 3x greater than or equal to 8. And now to get x by itself, divide both sides by negative 3. Now remember, this is an inequality. I'm now dividing by a negative number. I can do it. I can divide by negative 3. But after I do it, I have to flip the inequality. So it now becomes x less than or equal to minus 8/3. Now let's go back and do the second part of the second problem. Drop the absolute value signs. I flip the inequality and I make the number negative. Now I'm going to solve this. Multiply both sides by 5. 2 minus 3x less than or equal to minus 10. Subtract 2 from both sides. Negative 3x less than or equal to minus 12. And now I'm going to divide both sides by minus 3. Once again, I'm dividing both sides by a negative number. I can do it, but I must flip the inequality, and I get x greater than or equal to 4. So now I have my two inequalities. I'm now going to graph them on the same number line, and we'll see what we have. Now 8/3 is approximately 2 2/3. So really, if negative 2 is here and negative 3 is here, negative 8/3 is maybe right here. So that right there is approximately negative 8/3. So I'm saying x less than or equal to negative 8/3. So I'm going to do a bracket and then go off to the left. And over here I have x greater than or equal to 4. So here's 4, a bracket, and go off to the right. So once again, here's an example where the two graphs do not intersect. So the solution is simply you union the two intervals together. So on the left, negative infinity, with the parenthesis of course, to negative 8/3 with a bracket, union a bracket 4 to infinity. All right, so that's how you do absolute value inequalities. Hopefully, after you do some examples, you'll find these not too difficult.